Hello guys, today I'm going to discuss retrieval augmented generation pipeline. So first of all, we will understand what is RAG. So for that, we have to we'll go to google.com, then RAG pipeline. So it says enhances large language models output by fetching relevant external data before generating a response. Right. So it consists of two main stages: ingesting, chunking, and embedding data into a vector database, followed by retrieving this context. So it has basically two phases. One is indexing phase and one is retrieval phase. So in indexing phase, what we do, we upload the documents, we chunk the data into smaller parts. Let's say chunk A, B, C, and D. We feed these chunks into embedding model, and then embedding model will give us the embedding for every chunk. And then we will feed this data into the embedding vector database. And then what it will do, so it will create the vector for chunk A, vector for chunk B, vector for chunk C, and vector for chunk D. So up to this we have indexing phase. And in the retrieval phase, once user provides a query, for example, in this document, once user provides a query, it converts into embedding, and then it will do a similarity search in this vector database. And then using similarity search, we fetch the relevant data and then feed this relevant data into LLMs, and then it will give the response. Right. So why we do RAG? So large companies cannot do fine tuning every time. It costs a lot. So to avoid that situation, we use retrieval augmented generation. So here we say we have data preparation, information extraction, chunking, embedding, and then vector database. This is the indexing phase, and then this is the retrieval phase. So this is how our vector database looks like. If I'll go to the search engine and then search for vector DB, go to images, you see this, and the image new tab. So you see these dots are objects: boats, ships, football, bananas, orange, green apple, pears, everything. So like this only. So this is a Paris, India, same object, same kind of object. Eiffel Tower, same kind of object as compared to India Gate. And then we have dog and cat, same kind of objects. So how it works in production, how it works in a company when it comes to do the rack pipeline. So to do the rack pipeline, I will not show you how from scratch how to code. I have already written it. I'll just show you how it works. So this is indexing phase. So in indexing phase, first of all, as we can see that we have imported OpenAI embeddings, and we have splitted the documents, and then we have given the splitted documents which is converted into embeddings, and then we have provided the document as a chunks using this embedding model. And then uh, we have to store somewhere our vector database. So there are a lot of vector uh, stores such as quadrant, pinecone, cosmo. For now I'm using quadrant vector store. And then this is the collection name where all my metadata will come of every I can say data. So for example, if I load this research paper on artificial intelligence and its applications, so you see this is a machine learning uh, I can say description. It is one of the it is one of the applications of AI where machines are not explicitly programmed. So all this data will come under the collection name RAG. For example, there should be a page number also. So you see this page number 356. It's starting from 356. Okay, so it is starting from 356. So collection inside collection metadata such as author name, content, page number, these kind of things will come when retrieving from the uh, embeddings. So we know that LLM is reading from our in-house documents. So we have imported path. So path is used here to import this AI report. So this should not be an AI report. It should be okay. I have AI report.pdf also. So this is fine. I have imported the AI report. I have loaded this AI report and then I have loaded this AI report and then splitted the AI report into chunks, and then this chunk size equals to 1000 is 1000 means uh, read every 1000 page read every 1000 words and overlap 400. What does it mean? For example, we have this automation and robotics, right? And then this automation and robotics continues till here circumstances. So if the count of these words are greater than equal to 400, then from here to here my LLM will my embedding will overlap. So we will uh, continue having our accuracy while LLM is giving its responses. So that's what we are doing here using this text embedding 3 large and then quadrant vector store to store it into the database. Once it's done, we can say the indexing of the document is done. So I'll do it side by side. I'll try to explain side by side. So there is a library called LangChain. So using LangChain document loader, I'm importing the PDF loader. So using this PDF loader, I am giving the address of this PDF path and then loading it. So in the another library, another LangChain library, I'm importing the recursive character text splitter. So it is used to create the chunks. Here I can see it is used to create the chunks. So this chunk, and then this chunk is splitted, split documents, and then this embedding model. I have loaded this OpenAI embedding, and then embedding name is embedding model is text embedding 3 large. And at last, this vector DB is here, quadrant vector DB store from documents. Document is equals to chunks, and then embedding model should be the embedding model. And then this URL, which is running inside my Docker container, and then this is the collection name. So I'll show you my Docker compose file. So this is my Docker compose. Image name is quadrant. Port is 633. What does it means? This is the port number of my vector database, which is running inside my uh, Docker container inside this image. So I'm just mapping it into my local host. So it runs on my computer also. As we know that on Docker images is an isolated environment. So this is my indexing phase. So I'll run this now and let's see if indexing completes or not. And Docker is running. Let me check. Yes, my Docker is running. Is the error? to remove the certificate. Again, I will try to run. So as we can see that indexing of document is done. So how we can verify it? We'll go to localhost 6333 slash dashboard. And what is the name? Learning rag. So if we go here, we can see this. This is the metadata. And then this is the PyPDF. And if I go collections, you can see this. This is the segments. And cosine search is there. Gesture, search quality, screenshot, visualize is there. We go to graph, data panel. I just want to see that vector DB, this one, AI report.pd, AI report PDF, and then artificial intelligence and the future of teaching. So if you will go here, the VS code, and then what happened? Cursor. You see this artificial intelligence, the future of teaching and learning. Where is my quadrant? So this is the same PDF we can verify from here. So this is my indexing phase. So this is the quadrant DB. This is one of the vector database. I need to do the retrieval now. Same, we need to import the env file. We need to import the OpenAI embeddings. And then we need to import the quadrant vector store. Of course, we need to do the cosine search, similarity search, what we say. Import, load the in .env file where our API key is saved or written. And then we have to make the instance of OpenAI. Embedding model is same that we have used in the index.py. And then vector database from existing collection. This we have to make sure what we have to do in index. We created our collection and then we are retrieving the data. So we have to retrieve from existing collections. Okay. And then collection name should be the same. Learning rag in index.py and then learning rag in the collection name. And then embedding model is embedding model, this one. Okay. So user query, ask something or exit. If exit, break, else continue. Search result is do the similarity search of user query. Okay. And then this key I will tell what it means. Available data is, what I'm doing is I'm just creating a string kind of thing where I have the page content and then results.page content. What it means, where is the result? Okay, so for results in search results, we have page contents, we have title. Title means metadata, get the title. Unknown means if it is there, uh, get that data, else it should be unknown. It should not return any garbage value or it should not throw any error. author is, get the author. If it is there, return the author name, else it should be unknown. Page number is 0 plus 1 means every time it fetches the page, it should be incremented by plus 1 because it's a dictionary for results and results. Okay. And then this is my formatted string. This is the system prompt basically. What it says, you are a document ground research assistant. Instructions are use only provided context to answer. Okay. And then you may summarize, explain limitations and infer direction. So basically what this instruction means, I'm saying LLMs do not go beyond this. Just just follow the instruction and give the answers according to this only. So do not say that context is missing unless it is truly empty. Okay. Cite page numbers when possible. As you can see, I have also fetched the page number metadata. And then we see similarly, I have fetched the title and the author also. So this is my available data. I have because this is a formatted string, I have passed the available data. So use this system prompt to answer from this available data, right? So response is equals to OpenAI chat dot completion. Here I am using OpenAI API to create uh, to call the basically LLM. So model will be my chat GPT, and this is my role uh, list. This is my object. Role is system. Content is system prompt. So basically what I'm saying, an LLM is that your role is a system and the content which you will give me is this content. Do not go beyond this. Give the answer based on this data only. What it means, if a company has some data, use that data, give me the answer. Okay. And this is the question that I'm going to ask right now. And then I'm printing the response. Message dot content. Response is this one, OpenAI chat, OpenAI client chat dot completion dot create. Basically, what I'm doing here is I'm just calling an LLM based on this user system prompt and the user query. I will explain once again using this uh, diagram. This is my load env, importing OpenAI API key, embeddings, this one, and then quadrant vector store where we are going to do the similarity search. This one, the same vector store. Create the OpenAI client or instance, whatever you say. We are creating the OpenAI um, embedding model. And the model name is text embedding 3 large, and then vector database. This vector database quadrant store from existing collection means it has the data. Okay, during indexing phase, I'm just fetching it, relevant data. And then collection name is learning rag, embedding model, while true. While true I'm using because I do not want that it will give me a response at a time and then it exits. I do not want that. I want to keep asking the question. That's why I'm using while true. So this is the user query input. Take the user input, and then this, I think you maybe know this. Search result is vector db similarity search to the similarity search. K is equals to 8. So basically, uh, K8 means, think, what does it means? I'm forgetting. Uh, let's search it on Google. K is equals to 8. It's been a long time just forgetting these things. Okay. Understood. Actually, whenever I run a query, then it should be having a threshold of searching same kind of things, like the same, I can say, data or embedding from the vector database, and the limitation should be k. K means we can say a threshold value. So I was forgetting that, thanks to ChatGPT. And then what is my available data? I'm just creating a string, and then this is my page content. Get the results from this for loop using the search result. Go to the search result, do the similarity search, do the k. K means, as I have said now only, maximum or threshold value of the similar data. The title should be your results.metadata. Get the title if it is there, well and good. Get the data, else unknown will unknown. You have to actually unknown we do to, like, we can say, a kind of try catch here. If it is there, fetch the data. If it is not there, it's okay. Author, fetch author, and then fetch the page number. One thing you have to be uh, more cautious, that here if you say I have done is result.metadata.get, but here I am doing is result.page content. So in while doing the similarity search in a vector database, page content is always there. It is not a temporary thing, just like I have done in like just I have done like this in title. Okay, it should have to be there. That's why I'm not using metadata.get, and it is also not supported by this similarity search. If you will do this, you will get an error. Formatted string, based on this instruction, get the data, give the response. I'm loading here ChatGPT 4o model. And then this is my object inside this list. Content is similar. Content is system prompt for the role system, and then for the role user we have content of user query, whatever we ask. And then lastly we have to print the response. Let's run if it works or give any error. Gives any error. So it says ask something or exit. I've already written question. I'll just copy this one. And if I search this here, okay, let's go here. Search in the document. Let's check if it is getting the correct data from the document or not. Let's copy this, paste here. So the quote is, I strongly believe in the need for stakeholders to understand the cyclical effects of an AI and education. Let's check. AI in education by understanding how different activities we have the ability to support virtuous cycles, otherwise we will likely allow various cycles to perpetuate. One issue is there in the code. Okay. So we can see this, the author name, and let's check if it contains page number or not. Page 5, 5, let's see. Second. Okay, okay, it is taking from here only. Okay. So this is basically how retrieval augmentation generation works. What we have seen is indexing phase, load the PDF, load it here using the PyPDF loader, split it into the chunks, load the embedding model using vector store, which is using the vector store, store the embeddings, store the embeddings, and then give a collection name. Once it is done, go to retrieval phase, load the important libraries, create the instance of OpenAI client, embedding model, vector database from existing collection, as I have said, and then this is my available data. Fetch these data from the search result, and then this is the search result. Search result is coming using the similarity search from the existing vector database model. System prompt is this one. System prompt means instruction, get the data. Do not go beyond these instructions. So I'm basically telling LLMs to explicitly use these kind of I can say uh, rules, setting the rules, and then I'm getting the response of these available data using this ChatGPT 4.0 latest. And then role will be system, content will be system prompt, and then query will be user query. This is the question that you can also ask. So basically, yes, this was the whole retrieval augmentation generation pipeline. So what I have done, we have done the data preparation, we have done the information extraction, we have done the chunking, embedding, vector database. This is my indexing phase. This is my retrieval phase. Query, embedding, similarity search, getting the relevant data, LLMs, and then response. This is my vector DB. So yeah, that's it. Thank you for watching. And if you need this retrieval and index.py file, just comment it down, or I will just leave a link below to download, so you can just check it from there how it is working. Yeah, this Docker is very important. Make sure you have this Docker container up and running. You can set anything here. I am using 6333. You can give any port. Basically, should be this should not be changed. This can be changed, right? And then this is your dashboard from where you can see your collections. So thank you for watching and have a nice day. Thank you.